A network engineer is deploying a Linux-based virtual network appliance in an AWS environment using an EC2 Auto Scaling group. The architecture requires high availability, and the appliance needs two distinct network interfaces. The primary interface handles instance control, while the second interface must be used for internet-facing traffic. The company has a specific BYOIP pool, and the secondary network interface must be assigned an elastic IP address sourced from this specific BYOIP pool. Which method allows the engineer to correctly automate this configuration?
Option A, define both network interfaces in the launch template. Configure the primary in a private subnet, set the secondary in a public subnet, and configure the BYOIP pool ID directly in the network interface settings. Option B, use the launch template to place the primary interface in a private subnet. Use user data to execute a script that attaches a second interface from a subnet configured for auto-assigned public IP addresses. Option C, implement an AWS Lambda function triggered by an ASG lifecycle hook to attach a network interface and connect it to an AWS Global Accessor endpoint. Option D, specify subnets for the primary interface in the auto-scaling group launch template and include a user data script that attaches a secondary network interface and associates an EIP from the company's BYOIP pool. All right, everyone. Now that we've read the question, let's take a closer look at each option. Option A suggests we define both network interfaces in the launch template, configure the primary in a private subnet, set the secondary in a public subnet, and configure the BYOIP pool ID directly in the network interface settings. Now, although this sounds familiar, there is one slight flaw. If we're planning to permanently deploy two interfaces in the same subnet, it might make more sense to keep them within the same launch template. However, although this could be potentially correct, it's not as straightforward as some of the other options. Let's take a look at option B. Option B suggests we use the launch template to place the primary interface in a private subnet. Use user data to execute a script that attaches a second interface from a subnet configured for auto-assigned public IP addresses. Now, although this sounds more...
This question explores the automation boundaries of AWS auto-scaling groups. When you deploy instances that require specific network architectures, such as multi-homed appliances, you need to understand which configurations can be handled natively by launch templates and which require additional logic during instance bootstrap. Specifically, it tests your knowledge on the limitations of associating custom bring-your-own IP addresses with dynamically created secondary network interfaces within an auto-scaling context. I believe the correct answer is option D. Configuring an auto-scaling group to handle custom network interface requirements, especially when involving specific BYOIP addresses, is best achieved by combining native launch template settings with user data scripts. While launch templates can manage basic network interface definitions, they lack the flexibility to programmatically assign a specific elastic IP from your own IP pool to a dynamic secondary interface during the instance boot process. Therefore, a cloud init script via user data is necessary to perform this specific task. Regarding the other options, option A fails because launch templates cannot directly bind a specific BYOIP elastic IP to a secondary interface during the ASG-managed launch. Option B is incorrect because auto-assigning public IP addresses uses standard AWS-owned IPs, not your own BYOIP addresses. Option C is over-engineered and unnecessary. As an exam tip, always remember that when native templates fall short, user data is the standard tool to bridge the gap.